All right, so we're going to look at how to determine the number of subatomic particles in any element. So we're looking at protons. We got P for proton, which is positive. We got E for electron, which has a negative charge. And then the neutrons are neutral, and they have a charge of 0. So anytime you look at a periodic table, you're going to see a box. And so let's look at copper, for instance. So Cu is the symbol for copper, and it's going to have a number on top, which for copper is 29, and then on the bottom, 63.55, and that's the average atomic mass. Now, this number here is the atomic number, and the atomic number tells us the number of protons. This number on the bottom is what's called the mass number. All right, it's also the average atomic mass. Sometimes you'll see it as just atomic mass, various things. And the mass number is almost always not a whole number, like 63.55. It's always going to have a couple places past the decimal point. The atomic number is always a whole number. And so sometimes these things are in different spots, but this is the way that it is with the periodic table that you would get with the AP chemistry test, so this is the way we're going to do it. Now, the other thing we do with the mass number is we round it off to the nearest whole number. So 63.55 would be rounded off to 64, and the mass number is the number of protons plus the number of neutrons. And think of it as the mass number. Basically, electrons don't have any mass, relatively speaking, so it's not included in this number. And then both protons and neutrons have a mass of 1, so if you know the mass, you know the number of protons and neutrons. So we use this information to figure out the number of subatomic particles. So for the number of protons, we just look at atomic numbers 29. So we have 29 protons. Now, for electrons, for now, it is the same as the atomic number. Now, we're going to learn later when we learn about isotopes. Sorry, that's supposed to be a number there. When we learn about isotopes, that's not always true. This is only true for a neutral atom. But for now, if you have 29 protons, since the atomic number is 29, you're also going to have 29 electrons. So the one thing we have left missing is the number of neutrons. So this is basically like a little algebra equation. We know we have 29 protons. So we plug this in here, and we can solve that for neutrons. So basically, the number of neutrons equals the mass number minus the atomic number. And sorry, my writing's not that great. I'll try to get better. So to get neutrons, we would take the mass number, which is 64, minus the atomic number, which is 29. So we have 35 neutrons. And if I go back and label this, there's the electrons, there's the protons. So this is done exactly the same way for every element. If you know the atomic number and you know the mass number, you can find the number of protons, electrons, and neutrons. So let's look at one more example. So here we have fluorine. It's got an atomic number of 9. It's got a mass number of 19. So if the atomic number is 9, that means it has 9 protons. And for now, if it's got 9 protons, we know it's going to have the same number of electrons. So it's neutral because these are +1, these are -1, so they cancel out. And then to find the number of neutrons, we just take 19 minus 9. So we have 10 neutrons. So it's really that simple.